Here we go live. And hi everyone, welcome to Meshey build and release call. And hi everyone, welcome to Meshey build and release call. This is a bi-weekly call where we discuss all CI related systems of Meshery, the testing frameworks which is implemented in Meshery, as well as different workflows and other DevOps related stuff. So today is October 26th, and we are we have a couple of items to discuss today. But before we move forward, we have a couple of housekeeping items where we give newcomers a chance to introduce themselves. And I don't think anybody is new on the call. Zaki, would you like? I know like you have been here for a while, but you weren't on the call. Would you like to introduce yourself to others?
Hi everyone. Uh, I'm Mohammed Zaki from India. I'm a Golang developer. Formerly, I was Android developer. Then switched to Golang, and here Meshery to contribute to Meshery and learn about all the cloud native and Golang stuff.
Okay. Thanks, Zaki, for joining. Okay, so I don't think anybody else is new on the call. So moving on to our first standing item, which is our Meshery test plan. So let's discuss this again. So basically, I go over this almost on every of our call, and where I give an overview of how this spreadsheet gives an overview of different tests that runs on different workflows of Meshery and what scenario they cover, what's the specific action of that workflow, and basically this spreadsheet gives an overview whether it's being covered in our current E2E tests or not. So most of these are not being covered, but recently there have been several updates to our Meshey CTL specifically test, which started to cover a lot of different scenarios. But still a lot of work is required in this area. And basically, if I can give an overview of what E2E tests are, so if you go to Meshery, one of the Meshery's adapter, which is Istio adapter, and if you go to .github and go to workflows, there is this E2E test. What it does is that it tries to test the functionalities of this adapter and Meshery on different versions of Kubernetes cluster. It actually, what it does is that it first tries to start Meshery through Meshery CTL. Then it tries to start the adapter. Then install, once the adapter starts, then it tries to install a couple of the add-ons of Istio through the adapter. And then it checks through these assertions whether the pod actually comes up or not in this specific namespace. And if it does, then the test passes, and if it doesn't, then the test fails. And it actually uses another workflow which is in Meshery. So it uses this workflow, and the same workflow is being used by all the other adapters as well. So that's just the gist of how currently our E2E tests are laid for the adapters. And yeah, I think, and the results of all these adapters are actually posted to Meshery docs. So if you go to compatibility matrix and okay, if you go to so basically I think there's some bug which would be fixed, but if you go to compatibility matrix, there is an overview of different passing and failing of tests for different Kubernetes version, and it basically tells whether the adapter for that specific version was passing or failing, and those results are actually published from this workflow. And that's an example of E2E test, which is currently being run for Meshery Test adapter. And if I go back to the test plan, so that was the overview of this thing. I think a couple of people are already tracking this item. Specifically, I think Philip have fixed a couple of issues. I don't know if he's today on the call to discuss. But moving on to the next part of the spreadsheet, which is currently considering the other questions on this. Hopefully there might not be, but if there are.
Yeah, the E2 test one on the first row is for Meshery CTL, right? Installation of Meshery through the CLI. Okay, cool. So that's different from the adapters. Got it.
Yeah. I was just giving an example whether how
yeah, just an
adapters
example.
Yeah.
Of course, yeah.
So next is about this part of the spreadsheet, which gives an overview of different workflows for different repos of Meshery. Like basically, it gives overview of what kind of things are being achieved through a workflow. Let's say if we talk about Meshery build and release. So the work of this workflow is to ensure that the latest version of Meshery is built perfectly and is released. The different components of Meshery, that is Meshery CTL, as well as, okay, let me show you instead of, so those who are new and might not know about this. If you go to .github, you go to workflows, and if you go to build-and-release-stable. So basically what this workflow does is that whenever it runs, it updates the GraphQL docs. Meshery has GraphQL as well as API docs. It updates the GraphQL docs, it updates the API docs as well, REST APIs. Then it builds the image, Docker image, latest image, and of the Meshery and also the playground. And it tags them with the relevant word, basically Docker tags, then pushes them to Docker Hub. Then it builds the CTL and pushes it to Homebrew so that Homebrew users of Meshery CTL can directly install it from the core tab, which was recently added into the core Homebrew's tab, so that users can directly install Meshery CTL instead of first tapping Meshery CTL and then installing it. Then we also have Docker desktop extensions. So on each release, we also make a new release of Docker desktop extensions, which you can, if you're a Docker desktop user, then you can directly go to dashboards, Docker dashboard, and go to extension and search Meshery. And you should be able to run the latest and the greatest version of Meshery directly from here. So that's another way of running Meshery. The first one was Playground, which you can go to Playground, and if you don't have access, then I'll tell you later on the call how to get access to it. So moving back, then we also release the latest Helm charts for the specific version, and we also check if any part of the workflow fails, then we ensure that a email is sent out to Meshery developers mailing list so that it can be fixed. Any problem which is there in the workflow can be fixed, and the issue can be resolved and new release can be made. And at the same time, we also ensure that we update the playground deployment with the new release, which actually calls another workflow. So that's about the gist of the second part of the spreadsheet. I'll share the link in case you haven't have it. And basically this rest of the things are also about it, and also about different areas which are being covered in the workflows of Meshery. Similarly, in other repos like Meshery adapter and the adapters and Meshery repo. So any questions on this? We recently had a bug fix by Mario, which I think we'll cover later today, about the npm package install, the dev dependency. So we'll come to that. So any questions?
Yeah, I had a question on, it might be one topic back on the, oh, never mind. Debaditya answered my question, I guess. If I didn't mean to interject. I was just, we have this bug inside the docs and inside of our tests where I think Pranav had raised it a couple of weeks ago or more. And okay, never mind. It's on the agenda. I didn't know.
Yeah, I've already added it. Okay. So moving on to our other agenda items, I think Sandra would be next. Sandra, would you like to cover your item?
So sure, thank you. Hi everyone. I just had a question after finding myself spending in developer time world too much time on trying to figure out a solution for a specific issue. So I'm working, I've put a link in the docs on the issue. If it's something that we would like to do, we could navigate to the issue. So to just give more context, I was having a hard time just trying to figure out how to create a new path, a new tutorial based on the learning paths that are currently available, but using the playground, because I'm not familiar with how the overall playground works within this context. I'm not sure if I should install an item from the catalog, if it's a designer item, or if it's a visualizer item that I should just choose nodes for or specifics for, and just record how I did that, or if it's something else. So that was the question that I had, and the reason why I asked to join this call.
I have a comment. Hey, Sandra. Did you look at the contributor resources added in? Yeah, it's the third. No, but it's contributor resources there. Seems like there's a design spec at the second. Yep, there. I'm not familiar with this, so it might not be as helpful, but have you taken a look at that? Or maybe someone else has any other suggestions?
If you were to click on the playground link in the table of contents here, so back inside of that Google Doc, there's a playground link, and I'm not sure if that just points to the playground or if that, oh, okay. That probably points to the external playground. Okay, never mind. Cool. So Sandra's got maybe if I can describe it like this, maybe the juiciest question of the meeting, maybe. It's a wonderful question. Pranav, I don't know if you want to take a crack at this.
Yes. One thing I have not gone through the specific issue, but I know the gist about what it is. So one thing what you really need to do about fixing this is we need to actually mock our existing learning paths which were using Cataconda. Instead of using that as a playground environment, we have to use our own playground environment. But the document, you basically have to focus on writing a documentation of how user would be navigating between when they would be landing in the playground. So how they would, if they specifically want to, let's say, use Meshery Istio. So I think, so they first need to install Istio adapter. Then they need to have one of the sample application for Istio. And if the adapter is running, which they can check from settings page, like there are different ways of, I'm not sure why it's not documented, but basically what you have to do is if you want to do a basically learning path from Meshery with Istio, first you need to install an Istio adapter. You should check the connectivity of the Istio adapter from Meshery server. Then you can go to designer. There would be, let me just go. If you
So
go
if
to
I
designer,
understand is basically follow the current tutorial, which has a manual section where you can do it manually, and there's also a section where you can do it within the MeshMap, which is what I was trying to do, because I think I understood it correctly, because that was the preferred option to do it within the playground and record a tutorial. So
A
not to
video.
write a video, right? So not
Mhm.
so much write a documentation because that's what's already available. It's more transition to a video tutorial. So do the first part of the installation. If you click on the learning paths link and then go into a scenario, and the scenario will lead you to the playground. And you right now, when you click on the lifecycle module in the sidebar, it's either it's only for me, it's only configured to Meshery itself. So I have no other options. I've tried to figure out how to install, for example, Zuma and or Linkerd, but I'm just seeing itself. So that's where I get
It's still,
stuck.
yeah.
Yeah, Istio. I keep saying
you-
itself because I
It's
wrote
okay.
that in the discussion. And I wrote that in the
No worries.
discussion, and I know it's technically incorrect, but I corrected it on the discussion. So that error is stuck with me forever now. So yeah,
it's fine.
so that's where I'm stuck at.
Can you share your screen, or maybe just a suggestion, like when next time you have a problem, you could record what you're trying to do, and
This
then
is all on the discussion board. It's been on the discussion board for a couple days now.
Okay.
And
So
I think I also
discussion.
posted a link in the support channel.
Okay.
So that it's the very first issue at the top.
I see.
So that error no longer persists, but I installed the adapter.
Okay. Okay, this is great. Thanks. Yeah, this is very descriptive of what's the problem. There's even a screenshot.
I actually missed this.
Okay,
I
I
checked
see
it.
your point. Can you open the screenshot? I think I know why the problem's happening. Can someone correct me? But the mesh adapter URL is not supposed to receive a YAML, is it? It's supposed to receive a URL where the Meshery adapter is already deployed. So
Yes.
you're trying to pass the configuration, which I'm sure there's a good reason, like it's some kind of misunderstanding. Maybe we're not documenting this out thoroughly, or something, right?
Hello.
Anyone wants to
Hello, Sandra.
share their...
Hi, go ahead.
Currently, we have Lee knows about it that we have a problem in deploying adapters. It's long been that we are not able to deploy adapter because of a Docker socket permission error.
Okay.
So
So
Is that true?
once that error will be solved, you need to deploy adapter, and then that adapter URL automatically will be reflected in the above mesh adapter URL drop down, and you can select that adapter URL and connect that. But at the moment, this functionality is not working.
Okay, so it's blocked.
Okay,
So in Playground, we're blocked for deploying. Can we share docs about how such deployment would occur to Sandra? I'm sure it's in some other place, like, yeah, anyone wants to.
This means once it's been resolved, I can install the adapters, Zuma, Linkerd, etc. that are within the learning path, right? Listed within the issue. Okay,
Yes.
you know what? That solves the entire issue for me, I think.
But
because
then again, the YAML URL you shared, you tried to add, that is not the correct way of deploying the adapter, because that mesh adapter URL in adapters tab under settings is supposed to receive the URL of whatever adapter instance that's already deployed. Is that correct, Pranav? Or can you correct me if I'm wrong?
Yeah, it should be.
So that's not supposed to go there, basically.
This you can
Even when the
actually
error
go.
is fixed, this will still not work because but yeah, I think Pranav was about to share like a doc of how to actually get it installed.
If I get a link to that, I think I'll put this issue on hold and focus on other stuff until I get a go ahead when everything's a-okay for the adapters.
Yeah. Do we have an open issue for that Docker port problem in Playground, just so that Sandra can know, like take note of when that's fixed? Like,
Yes, we have. I share that.
sure. You can add it to the meeting minutes. I mean, that's good as well.
Okay, 1 second.
Or
Uh,
sure, thank you.
I think
But I didn't want
Yeah,
to
thanks,
like
guys.
hijack the meeting. Let's take Pranav. Let's
You did
take
no
Pranav.
such thing. You did no such thing. You provided as much clarity as it is that, got to where at the point we are right now. Thanks, guys.
Excellent. Yeah. Thanks to Zaki too. He provided this very useful blocker we weren't aware of.
So basically, I just recall that when we added the feature for deploying adapter, I think we didn't document it. But I'll go back, and if it's not there, then
let's add an issue for that, and
yes,
we can get some help.
Yes. Okay. So I think next item is
there. If we have time at the end to come back to this, there's a lot more to say. There are actually Sandra is blocked in one area, but there's an alternative path, and that's even easier, and she's not blocked there. And so it'll take, I think I would give a full explanation, and so it would probably take 10-15 minutes. So maybe just, if we make it through the rest, we can come back.
I think next item.
Okay, so should I go next? Maybe would you guys want to go over the Meshsync updates first? Seems like that's really important.
That's got Daniel's name on it.
Yeah, I'm having spotty internet. Can someone confirm if I'm audible and consistent enough?
Yes.
Okay, thank you.
Yep. You'll have to pay $1 every time you ask if you're if you're audible or just kidding. But we usually just start like with our update, and then someone will let us know if just to make things faster. But it's just a small joke. Lee gets
Yeah. I do know. I think it was just because I knew I had internet issues, so I just wanted to confirm.
Oh, cool. It's fine.
Just because of that.
We'll spare you the $1 this time.
Okay. I'm not being let go of easily. Okay. So I'll talk about two PRs that I have up. Okay. I can get this working. Okay, so I have two things on the table to help us control the amount of compute consumed by Meshsync on the server. There was a proposal to have some of the particular items or things that Meshsync monitors. We wanted to have a dynamic way of configuring them so that we don't chew our bandwidth on resources that maybe we may need or we don't need. So there was a proposal to extend the Meshery operator, the custom resource, to include the configuration that the Meshsync uses at the moment, so that we can either throttle up or throttle down, whatever we are looking at. So I had so the changes in two parts. We have the changes to the CRD, and then on the Meshsync side, having Meshsync read from the CRD and then using those configurations to as what it's going to listen to and what it's going to subscribe to. Okay, so I got a bunch of reviews from a few of the contributors. We have Isuko, mainly some bit of code compatibility and ensuring that we have something consistent across the board. So I was able to resolve the issues that were brought up, except for one, and that is adding the new configuration to the Meshsync status. So I'm still working on that one. But then there was also some bit of concern from Uzea, who was of the view that we are bringing a gun to a knife battle. We'd rather maybe simplify instead of using a whole custom resource to just define a few configuration items, there are a few other options that are a bit simpler, like using the config map or environment variables. So this maybe eventually what I felt for using the CRD was more of a convenience purpose, or the general feel that we wanted to go towards that direction because it's going to provide more flexibility towards future enhancements. So this, if anyone else has a view that we can we can extend this discussion. Do we need to, are we going so far ahead in using a CRD, or we can drop back to this primitive Kubernetes objects and then we can use them accordingly? So that's a point of discussion. So on the second side, we have the Meshsync, and now having that custom resource apply to Meshsync. So the only overarching thing that I have remaining here is once the CRD is confirmed and we can have it as part of Meshsync, then there's some form of code duplication, because I'm having to repeat the CRD on the Meshsync side so that we can have that struct, and then I can deserialize into that struct. So once the Meshsync side is approved and it goes through, then I can actually use the link to that custom resource without having to repeat it here. And then the only there was another issue that was raised by Isuko. So essentially, if we try and access the CRD and we don't get it, should that apply as a warning or just an information point? That was one of the discussions. I felt it was we should have it as a warning, because the ideal configuration should be using the CRD. So we'll just issue a warning, but still continue on with the default configurations for this one. The only other pending thing that I have with regards to Meshsync is I want to add a few unit tests to, especially for the different scenarios that we have when we get a CRD, when we don't get a CRD, and what happens, just to be confident and double check that the code works exactly as is expected. Yes, thank you.
This one's exciting. Yeah, I don't know, Daniel, it might be to one of the questions that you were asking, it might be that that there is a new that there is either an augmentation to the existing Meshsync CRD. Perhaps, like I think you ended up naming one of the attributes config in the. Did you create a brand new CRD, or did you just augment the existing CRD called Meshsync?
I augmented the Meshsync one.
Okay, nice. Yeah, it might be that it's worth a thought that perhaps the way in which people configure the config attribute, one of the new ones that you're adding, is via a config map, such that it's such that they don't have to go over to a big long field and type in a bunch of JSON or what have you necessarily there. I guess that would be about the same thing that they would do with a config map, but it would be arguably perhaps cleaner to the extent that it's its own object that has its own life cycle and could, can independently be updated, and its updates would be reflected inside of the CR. Like, I don't know, it's nice to have. It's more complex usually to have more moving pieces. It's also generally a little more sophisticated and powerful to have them. I'm having a hard time teasing out many more considerations around whether or not one is better than the other. I do think, at least in so much as I understand, it's probably not the end of the world either way if we figured out that the way that we initially chose was not the ideal, because it is really just about where are you directly configuring the configuration, the settings inside the CRD, or are you doing it in a config map and relating the config map to the CRD? I've certainly seen CRDs that do that expect to have a config map mapped or related. I don't know. It might be I don't know. So I'm not educated enough to make a compelling argument either way, or really offer up justification either way. My gut says, hey, we should probably be using a config map. They're purpose built for that, for such a use case, and so probably there's something to that.
Although, are these secret values like sensitive values? I'm just looking at the issue and it says that desired behavior is to add Meshsync configuration to the Meshery operator, but that's a bit high level. Can we define exactly what we want to pass across to the Meshery operator?
Yeah. And so, yeah, no, they're not secret, or they're not sensitive. Yep. So that's a good question. I mean, we do want one of the two or all of the above things to happen. There's any number of things for Meshsync to do. To the extent that Daniel finds even more of his stride here, or potentially others as well, Meshsync can it can become more and more capable, more. So if we describe a couple of things that, to answer Mario's question, it'll help. It won't really help flush out the config map versus config attribute, but it will help flush out the initial value gotten from these updates. There's a couple of things that Meshsync would ideally do. And I'll share this slide as a backdrop for helping ensure that we're all sort of rocking this in the same way. This is the Meshery architecture deck. There's this is kind of cut off at the bottom, but we can fix it. There's this is just a sequence diagram. Are you guys able to see the full screen? It looks like
loading.
Yeah.
Okay.
Just loading with a ellipsis.
I think it says that it's paused, but why would it be paused?
But while that it loads, I think I get the idea. So there is a hard-coded config file that's part of the source control, and we want to avoid needing to get that configuration data from that and be dynamic. That's just what we want, right?
Yep.
Cool.
Yeah,
Yep.
Yeah,
Config map seems
they must have
built
built
for
it
that.
for
Yeah.
Screen share is not doing what it's supposed to do. Hopefully this is large enough on everyone's screen. Anyway, it's just a sequence diagram. And it's not, it encompasses what happens with Meshsync as a controller. Meshsync is part of the Meshery operator package. Meshery server, when it starts up, when it connects to a Kubernetes cluster, it deploys the operator. It applies some configuration to the operator, and the operator looks around and looks at these custom resource definitions, these CRDs, and determines that the operator, needs to run an instance of Meshsync, and it needs to run an instance of the broker or NATS. So these two controllers. And to use a different example to drive this home, so if that was it was just like install was the only command sent and the only configuration sent to the operator, well, it would do what I just said. But if you're running this in an environment where you're already using NATS and you've already got an infrastructure of NATS deployed and you don't want yet another NATS server, you'd rather just have Meshery operator use your existing NATS, it would be great to be able to configure, add some configuration to hand it to the operator and say, don't use that instance. Here's your endpoint. Use this NATS. Or, of the NATS that you're going to run it on a different port. That type of configuration in the same vein, it would be nice if users or Meshery server can give the operator configuration to control Meshsync and how Meshsync behaves, because it has an out-of-the-box behavior. There are a couple of use cases for why it is, or what it is, and why it is that people would want to adjust the settings of Meshsync. One of those has to do with what Daniel mentioned, which is around throttling or being more selective with identifying what's interesting and what infrastructure to watch. So Meshsync, as it spins up, it immediately talks to the Kubernetes control plane, to Kube API, and says, hey, I'd like to subscribe, or I'd like to watch for any changes, any events that occur to these objects under your control. Maybe it's a pod, maybe it's a deployment, whatever those objects are. And what you can race your Golang against the Kube API, all the changes that go on. Like, you can overload things pretty fast. And it would be nice to be able to, in this vein, in this throttling / what's interest in the ability to control. Yeah, there's a number of use cases, but one of the use cases is around performance and around what's interesting and updating that in real time. If a user of Meshery goes over and looks at the visualizer, as an example, or they look at the dashboard of Meshery UI, I'm trying to find it just to. They're looking at the here. They're looking at the visualizer and they're looking at all the changes that are going on, and they're like, whoa, I can't even understand all this. Hold on, let me filter on just the things that are of interest to me, and okay, I'll just look at those. Now, Meshery server, it can sit there and perform that filtering while at the same time still receiving a flood of information from Meshsync, and Meshery servers having to kind of filter some of that out. Or alternatively, as the user begins to apply a filter here, Meshery server can in turn speak to Meshsync and say, wait, thanks for all that info. Why don't you back off? I only care about this right now. I'm gonna update my subscriptions. I'm gonna update what I'm watching for. That's one use case. And a nuance to that might be, actually, I'm still interested in all of those updates for all those objects, but maybe specifically not this type of an event on that object. Or I'm interested in all the same objects, all the same events, but I really only want to sample like once every minute. Like, I just don't need, the play-by-play. So that there's those are like three different concerns, I think, that I just mentioned, sort of in the same vein of like controlling the flood of updates. When you take this consideration and you do two things to it, you say, is Meshery a multi-user tool? It is. Oh, so different users might want to be seeing and watching for updates on different for different different intervals, different objects, different. Okay, goodness. All right, so that's something to consider. The second thing to consider is Meshery a multi-Kubernetes cluster manager? It is. Which is to say, if you have 10 Kubernetes clusters, you might have 10 Meshsync instances or 10 Meshery operator instances, all sending back to that central control, that bottleneck now, Meshery server, just trying to drink from the fire hose, trying to keep up, and then and so those are two things that exacerbate the issue. That's one set of things that we want to accomplish with additional configuration, is in real time to say, hey, Meshsync, back off or get more. The second sort of use case around this is that the way that Pranav and others will describe Meshsync, and I'm going to go back to the other, is that, and I think maybe Daniel might articulate it in this same way, is that Meshsync should be a high performance machine. And here's a different one to look at to enjoy as we speak. This one's maybe a little more clear in terms of what a mesh. So Meshsync should be a high performance machine. It should be able to. There are two other use cases that it should be able to do. It should be able to spin up, take a look around the cluster and say, oh, so the cluster that I'm in, it's a 200 node cluster. It might take me a little while to go discover all of what's in here. We're talking many megs, hundreds and hundreds of megs of JSON for it to go through and discern, come to understand what all is out there and show it back to the user, because the user may not know, hey, I don't even know what I'm interested in looking at yet. Why don't you let me know what's out there? And so Meshsync takes a huge breath and says, okay, I want to go look at 200 nodes and we'll see what I do. And well, that can be a super expensive problem. Well, there's an opportunity for configuration, which is to say that there would ideally be discovery tiers or tiers of discovery. These various concepts are in
it's
different,
like a priority queue of what to discover first.
Like a ping sweep, if you will, of like a network monitoring system. If Meshery is the network monitoring system, or Meshsync is the network monitoring system, and it says I have 200 nodes or I have 200 network devices, I don't know what they are. It could be a web server, could be a mobile device, could be a Mac, could be a Linux server, could be any of these. Could be a wireless access point. So to go through, let's say there's 200 subnets, to use the analogy, you would do an ICMP ping sweep. You do a ping sweep super fast and just say, hey, how many of these IP addresses, of which there are 64,000 something, are actually returned back and respond with something? Oh, out of the 64,000, only 200 are actually live. Oh, okay. I don't have to go I just do it. So you do these tiers of discovery.
So each tier gives a more granular level of detail than the prior one, right?
Yeah.
Correct.
Yeah, and so
interesting.
It would be an ideal point of configuration, because it might be that someone were to say, look, I'm going to deploy the operator over here. It does have 200 nodes in that cluster. I'm only interested in these 40. And by the way, they all carry this taint. They all carry this label. And so Meshsync, here, I want you to subscribe for all the events, but under this taint, under these 40, not the other 160. So Daniel, that's one of so tiered discovery, Daniel. This is the last one, and it is, what's said right here around fingerprints. Oh, I missed. Which is to say, which goes back to what I was saying before about Meshsync potentially being performance machine, a highly tuned machine that unto its own with sort of its default configuration was kind of dumb or is ignorant until Meshery server comes over and configures, uses these CRD enhancements that you're doing and applies configuration. One of those configurations would be something like basically what we were just talking about. It has to do with discovery, and it would be around fingerprinting a thing. Hey, if you do a kubectl get pods and it shows you a list of pods, now they've got these funky names that were just auto-generated, and there's 20 of them. Now, one of those is this Prometheus instance server that you deployed. Well, how do you know which one of those is the Prometheus server? Could be any number of ways. It depends on how you deployed it. Maybe you labeled it. Maybe you look at the container image, the name. Maybe you blah, 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 blah. There's a bunch of, well, maybe you port scan it. If 9090 TCP is responding and it has a /metrics and it's giving you metrics back, it's probably a Prometheus, and it responds to PromQL. It's a Prometheus, but oh my gosh, wait. So you had to actually go through and ask a bunch of questions. What was the container image name? What is the version number of it? What ports are open? Do those ports respond to TCP requests? Do those requests then respond to a specific application level PromQL query? This becomes a fingerprint, a set of composite keys that, if all are satisfied, means, at least with all the confidence that we can say, that thing of the 20 pods, that's a Prometheus. Oh my goodness, that is so much more helpful to users when they load up the dashboard, and instead of just seeing a bunch of blue circles, pod, oh, one of them is orange, and that's a Prometheus. Oh, maybe I'll use this Meshery thing. This is helpful. So fingerprinting. Now, where do the fingerprints come from? Probably not Meshsync. What? Yeah, it's supposed to be dumb. It's supposed to be ignorant. It's supposed to be told what to do, but it's supposed to be super fast. It's supposed to have tiered discovery. It's supposed to have multiple of them all working, in one per cluster, all feeding back. They should be highly configurable. That's what Daniel's working on. Well, where would the fingerprints come from? Well, historically, we put a lot of investment into Meshery adapters. And when a Meshery adapt, and this is in part what Sandra was, if she's still, yeah, it was sort of touches back on what she was talking about with respect to Meshery adapters and their current function. We used to put tons and tons of time into them, and they're still valid, they're still good, we still use them. One of the things, and I'll characterize that a little bit differently in a moment. I'll say one of the things that they've always been intended to do, and that they currently do, is that if this adapter is called Meshery linkerd, well, that one has some specific knowledge of linkerd and understands to a fair degree what linkerd can do and can control it and all that. And so, if you want to deal with linkerd, probably load up that adapter. When that adapter container spins up and it registers with, and I think this is the sequence diagram here. Oh, or a config map containing, oh, geez, Daniel. I might have said this a year ago or something, You guys don't know how many times I'm almost certifiably insane from how many times. So sorry, my mouse. Hopefully you can see it a little bit, that when the adapter spins up and it goes to register with Meshery server, it registers its capabilities. Well, what would those be? Well, it'd be a collection of different things. What lifecycle management operations can this Meshery linkerd adapter perform on linkerd infrastructure? Well, it's going to register those operations, and you literally see those in the UI that Sandra's trying to get to, but she's bumping into this bug. It could also be registering the fingerprint for linkerd. It becomes a vessel for linkerd's specific handling and of how you were to qualify what makes a thing, an entity, a pod, a deployment, a service, or a linkerd. Well, I can go out to my Kubernetes cluster right now and I can create a namespace called linkerd. And that would be the same namespace that linkerd control plane runs in. So if I create one called linkerd, does that mean I'm running linkerd? Probably not. It's a signal, it's a sign, maybe. So these fingerprints need to be a composite, a set of prints, a set of keys that are, well, painfully, not necessarily something that you can, across the 220 something integrate model, types of infrastructure that Meshery manages. It's unfortunate, if you guys figure this out, please let me know. But it's not necessarily the case you can programmatically ascertain what that fingerprint should be. And so these fingerprints and the composite set of them probably need to be, it's a point of manual curation. It's a point of manual, some human coming over and saying, hey, yeah, if it does this, if it has these properties, these attributes, you're probably okay. Now, at some point, the fingerprints can only take it so far with so much. So anyway, that you would store the fingerprints in an infrastructure specific adapter, like a Linkerd adapter or an Istio adapter or whatever. And then when the adapter registers all of what it's capable of, and the fingerprints, Meshery server in turn would say, oh, thanks for the fingerprint. I will give it to survey. Yeah, that's right, Daniel, to Meshsync. Or right, and the Meshsync. Okay, now, well, why does Meshsync? Well, this is an open question. It's like either Meshery server hangs on to the fingerprint or it passes it along to Meshsync. And it's a question of like, hey, which one of the two of these processes is going to perform that additional task of interrogation? Kubernetes, Meshsync was watching for Kubernetes objects and events, and so it watches them. It's like, I see that you're an object, I'll pass that along. Either I'll stop you here, put you under the spotlight and interrogate you. Who are you and what attributes do you have and how long are you gonna be in the country for, and is it business or pleasure? And or a Meshery server could do that. And there's some there's a discussion to be had there about what might be the right place. But there's additional overhead in terms of that. The closer you do that to source, the less overhead it is on the rest of the system. The closer you do it to the central brain, Meshery server, the more of a bottleneck kind of it is, but also the more powerful it is because it knows about more things, even if anyway. Last thing to say, that is that with those fingerprints, maybe
sorry, just a question. Does Meshsync, is it able to scale? Like process things in parallel and then merge them and then, but maybe that's one of that's good. It's one of the things that that it would ideally do. So if right now the scale that it has is just one Meshsync per Kubernetes cluster. Now a cluster might have 5 nodes, or it might be really small or really huge. To the extent that they're huge, the idea is that one of the configuration settings that we should be able to tell the operator, say, hey, operator, we would like 2 replicas of Meshsync, please. Please run 2 of these. Oh, by the way, Meshsync, as I configure you, each of you now, because you're twins or what have you, I want you to take A through M objects and M through, I want you to take all deployment services and blah, blah, blah. You guys split it up, like shard the data, not shard the database, but split up the responsibilities so that they can. Yeah, like data level parallelization. I mean, split them up and then they work on that separate subset each, and then they can join it once they process it, right?
Yeah, exactly. So the last piece to this is, and I know everybody's sick of hearing me. It is, well, it's what Partha Dada was hopefully, he was kind of demoing this yesterday. Inside of Meshery UI, let's say that, Meshsync is discovering all that infrastructure, and some of it is fairly obvious that that discovered thing is it's an API 6 ingress controller. Or not, maybe we're only 80% confident, or maybe we're 100% confident, but that doesn't mean that the user wants us to do anything with it. There's this human interface that will, right now, it will look like, it will, Partha was demoing it, people will need to come over and go through a registration process to just tell Meshery server, hey, ignore that, ignore all these, don't touch those, how dare you, don't mess with them, or monitor these, or start controlling those, or connect. Yeah, that's a Prometheus server. Go ahead and connect to it. And I do want you to show me the metrics for things in that class. So that there'll be some human interface. Like it's okay if the fingerprint only takes things so far. So even if it could take it all the way, 100%, 100,000%, that's a Prometheus server. The user might say, yeah, and get your stinking hands off that. Like, yeah, don't touch it. Even though you can start pulling metrics from it, don't. And so the part of the question is like, some of the things that I've just said, it's like, it might be really nice if you configure Meshsync, if you just sort of stop that at the head end up at Meshsync before we even get all that data into Meshery server. Some of the things that I've said, it's like, well, you'd actually really want to do that in Meshery server. So a lot of what I just said is written into different design specs, I think. Some of it, I think, is published in the docs themselves as like a future-facing capability, probably under Meshsync. Now, I'm sure we'll be repeating this in a couple of months, maybe, hopefully not, but with all that background, if you go and try to read this, it should reinforce the things that I'd said. Hopefully, if you see things that are missing, this speaks in advance of what capabilities we have today, and we should try to make sure that that's clear. It talks about composite fingerprints, what I just said. Oh, I can't believe I gave the same example. And then the doc is kind of incomplete. Tiered discovery, what would that mean? So, okay, fine. Daniel's like, okay, great. But can we like talk about it here and now? I got, PR's been hanging out. What are we gonna do? Are we gonna merge it? Are we gonna, we need to pick one of those use cases. I think it's about 6. It was like 3 of them have to do with throttling, identifying what's of interest. Like, hey, I'm only interested in sending events for deployments, not for everything else. Or I'm interested on deployments, but only on the delete events for deployments. Like that whitelisting, blacklisting, or that identification of what's interesting. Perhaps that's the one of, maybe that's the use case to go after initially for Meshsync. And I think that falls fairly well in line with what your prior focus and thinking had been, Daniel. Part of what you had been thinking is like, oh yeah, we'll do some throttling. It's like, that's a can of worms. No, it's a fun can of worms, but I wouldn't wish that upon you right now. Or I would wish for a working functionality in a week or so, as opposed to like the month or more that it would take you to really do throttling and hit that use case. Like that's something else we have to. Yeah, I mean, that's, so I think the question comes down to is, should we do a config map or should we just accept this thing? Maybe the way that you can help answer it is exactly what how we got started on this is for the use case of keeping a list of what is interesting by way of object, resource type, deployment services, and event kind or event type, deleted, created, change set, or whatever it is. Having that list, if you use that as your use case for the type of configuration that would be put into this new attribute or this new config map, I think you'll be in a position to form a stronger opinion, or you'll be able to prove that.
Okay. There's a lot to compress, but I sort of picked up a few things that this is a starting point, but we are growing further. So I sort of picked up that a CRD would be much more, a custom resource would be much more suited for the long term of this particular feature, as opposed to a config map for the current. And then should it be a CRD, then we don't, it should have its own controller and its own life cycle. So not an extension of the current Meshsync CRD. I picked up those 2 things.
Yeah, And what my gut tells me is that, so right now we have 2 custom resource definitions, 2 CRDs, one for the broker or NATS, and one for this is for everybody else's benefit, I suppose, and one for Meshsync. And I suspect the one for Meshsync is probably pretty light in terms of configurable items. Like ideally, we would be able to configure some of its networking or something, but my gut tells me that there needs to be an attribute called interesting resources. There's probably a better name for the attribute, but interesting resources, and it expects a config map to provide that tuple or whatever it needs to be in terms of like resource name and event type. In that sense, we're considering that it's a whitelist thing, but you might want to consider that it's the inverse as well, as like it's a blacklist saying, well, I know that Daniel, can you still hear me? Anyway, I'll repeat it on Slack. But,
we can hear you, but Daniel froze, I think. Yep. He's just staring at BlackBerry, like frozen.
I know we're over time, but for Sandra, one of the things that you could actually forego waiting on the Meshery adapter bug fix. That certainly needs to be fixed, Zaki. But however, many of the capabilities that Meshery adapters have, so too does Meshery server now have. Over its evolution, the server has gotten more powerful as well. And here's the playground. I don't know if there's fudge. This happens to some users. It's happening to me.
You click on try again. Does it help?
Yeah.
Nope.
In part, it has to do with how I navigated there, I think. If I navigate a different way.
Yep. Just refresh the page. Good.
But it is a bug, and we do need to fix.
Yeah.
For Sandra, what I was going to say is that you can go over to the components, go to Cloud Native Network, whether or not, for sure, all of the Meshery adapters are not connected. So maybe the AppMesh adapter is connected. I doubt it. But these components are present anyway, because anymore we're having Meshery server preload all those things. So you'll find Istio listed 3 times. And so many of the Meshery server can actually provision Istio, an instance of Istio, like this control plane, without a Meshery adapter. So it's slightly confusing, and Pranav might recall the manner in which, okay, so this component was not registered by an adapter. It is registered by a Meshery server. So Meshery server can use this and try to deploy an Istio control plane without having a Meshery Istio adapter connected. So that this is in this vein, what I'm saying is you wouldn't have to wait for the Istio adapter, for the Meshery adapter bug to be fixed. You can move forth with provisioning Istio using these components here. I know this is still confusing. I'm going to say that, well, how would I know which of those components under Cloud Native Network, like, how do I know that these are from an adapter, or that these require an adapter, or that they don't? One of the ways to do that is the thing that Partha Data is to be enhancing and delivering, is you'd go to settings, you'd go to registry. So inside of Meshery server, as components are registered, so an adapter, Meshery server talks to itself when it starts up and says, I've got tons of capabilities. I'm going to self-register all these capabilities. If an adapter connects to Meshery server, it registers capabilities as well, registers these components capabilities. We would go through and we would find, we'd go to we would find Istio and look at the details and look to see who registered that Istio component that we were going to use. And so this UI is terrible, and that's why it's being rewritten. And that's why I'm pushing on Python as much as I am today. But you'd be able to tell the difference here, and then you can correlate.
So considering we are over time already, so I think we can cover rest of the items on our upcoming call. So I think we covered.
Just
Okay.
wondering on this, sorry to interrupt, I know we're out of time, but on the learning paths, I tried to go to the labs, but all they say is sign into Meshery Playground. So how would it be possible for anyone to like replace their prior steps? Like, is there some other place besides Service Mesh Labs, like this link I'm showing right now, so that they can replicate those steps? Like, they're not there anymore. I remember Calcote used to like appear, but that's not the case anymore. So that's another blocker for Sandra. So let's, yeah, I don't know. Is there a quick answer, or should we can just talk about that next call?
Ask the question one more time. I don't think I got it.
Yeah, so if you open that link and you try to open one of the learning paths, it just shows sign into Meshery Playground. So then the Calcote environment doesn't seem to appear. So recording the same steps that used to show up is not like, how would Sandra go about doing that if they're gone?
Yeah, right. I didn't realize, I think I've used some confusing language in this issue. I haven't read it, so maybe it unconfuses itself, but at least at first blush, I think two terms were, I guess I didn't, it's just that you'd have to really know this. There are two concepts.
There used to be a Calcote scenario, but what we need a video replicating that using Playground. I mean, that's what I get. But if the Calcote scenario is gone, it'll be, well, where those steps?
You need the context that I'm about to give you.
Okay, go ahead, please. Yeah, sure.
Which is, these are Layer 5.io, Learn, Service Mesh Labs. Great, there's 10 of them, or what have you. And there's some different categories. Calcote is no more, or it's an enterprise feature from O'Reilly now, maybe.
Oh, okay.
This is great, and it is what, great. The thing that isn't necessarily as obvious, or what is technically being said in that issue, is that learning paths, not the labs, well, it's when we go back to the site, under resources, there are interactive labs. That's where we are right now. Just a collection of interactive labs, or there are learning paths.
Learning paths.
So over here, there's two paths that have been set up, only one of which is live. In that path, there are two courses. There's an intro course and an advanced course. Okay, so here's course one, course intro, and advanced. Now, in each of these, in the intro course, there are like 10 chapters. And you can do your chapters specifically on Istio or specifically on Linkerd.
Linkerd,
yeah. So you get your choice of like what tech you want to walk through. Here are screenshots showing some of those things. What it was, so the interactive labs and the learning paths highly interrelated. Hopefully it had been the case that as you're walking through a learning path, and you get to a certain part, and they're like, and we're like, hey, do this, do that. Oh, if you want to do it live, go ahead and use this interactive lab right here. Well, that's no more what we would ideally be saying, both here in the content of the course, we would be saying, do these things. Also, if you want to do them live, sign into the playground right here. And also here's a video of someone having done it in the playground, or display, you guys are right, like displace Calcote with the playground, and that could be done we could sort of reference it in two places. If someone wants to go through a structured course and follow through all the labs and get to the end, and at some point hopefully would have a certification, great. And a part of that course content would be playground video recordings, or connect to the playground and do these things. Alternatively, if someone's like, no, I really don't want to go through a structured course, I just wanted, a la carte, ad hoc to pick up, it was really just this, I wasn't sure how to do this. This would be the same content, two different places. Confusing. Sandra, has the veil lifted, or I mean, did this help illuminate? And I know that you're still going to be kind of stuck on some of the particulars about like how to perform, how to recreate, how to perform the task at hand. Meaning, as you go to this section, just randomly, okay, if the user is supposed to have, if the user can use the CLI to do this, they also can use MeshMap to design this and have the same effect as to what this is. Ultimately, there would be like potentially 3 artifacts, maybe even 4, that would be produced as part of the effort that you're doing. One is what you guys are saying, maybe a video recording of the playground, maybe some updates in the docs here. Another one being that there would be sort of, hey, when you're all done with the chapter, here's the solution section, like here's the answer. Like you're working through a math problem and like you can't figure it out, go to, all the solutions are in the back, so go ahead and go. It'll be like, here's the solution. What would the solution be? It would be,
I'm afraid not.
Catalog. It doesn't help at all. Okay, so it would be the catalog though, and so this would be the thing that would have been created inside of so I don't know. Yeah. Yep. I guess I'll wait for you to articulate different questions and I'll try to answer them, Sandra. Or we can try another session. It might have been that I was trying to hit it real fast.
Okay, so considering there are no more questions, so we'll see you all on the next CI call, which will be, I think, 2 weeks from now. So thank you all for joining. See you all on the next call. Bye.
Thanks, Mike.
Thanks. Yeah. Bye, guys.
Bye.
Bye. Sorry, my internet cut off. I think I'll follow it back. Lee, you said your text on Slack. I will be looking forward to that.
Okay, nice. I'll go do that
Thanks.
now.
Okay.